All right, let's start out with just a couple review questions from Friday. So we talked about on Friday, the first thing you need to do is make sure that it's written as a single log. And we have that going on for the first one. We've got log base 4 of 3x minus 2 equals 4. So we've got a single log equal to something, and that's what we want. So that was kind of the first step. The second step then was to take that and write it in exponential form, or write it as an exponential equation. So our base is 4. So we've got a 4. Our exponent is going to be 4 as well. Remember, our exponent comes from there. And then that's going to equal 3x minus 2. 4 raised to the 4th power is 256, I believe. So put that in your calculator. You get 256 equals 3x minus 2. Add 2 to both sides. So 258 equals 3x. Divide by 3, and you get x is equal to 86. The second one, we've got log base 2 of 4 plus log base 2 of x equals log base 2 of 36. So we don't have the single log thing going on. So we've got an expanded log equal to a single log, and we can't have that. It always has to be a single log equal to something. So we're going to condense this to a single log. So the base remains the same. Because we're adding these two, that means you multiply the ofs. So log base 2 of 4x is going to equal log base 2 of 36. So you've got a single log equal to a single log with the same base. So we've got log base 2 of 4x, log base 2 of 36. If that's the case, then the ofs have to equal each other. So 4x is equal to 36. Divide by 4. X is equal to 9. Okay. So those are just a short review. And just a quick review of what we did last week when we solved logarithmic equations. Today what we're going to do is we are going to do part 2 here, solving exponential equations. So solving something like a to the x is equal to n, where we've got our base a to an exponent and is equal to something. And kind of the same basic things are going to apply with exponential equations as with logarithmic equations. You have to get a single base to an exponent equal to something. When we do this, one of the nice things about this is that now we can use the change of base formula to help us do this. So we talked about the change of base formula last week and said that the change of base formula says that if I have log base b of a, that's the same thing as the log of a divided by the log of b. And we can just put that right inside of our calculator, making sure that we put in the parentheses that we need to put in and make sure that we put, hit the equal sign, hit the divided sign when we have to. Okay, so we talked about that last week. So a couple of examples of being able to find solutions now. We can find the solution to log base 3 of 6 by using the change of base formula. The change of base formula for log base 3 of 6 says that we can solve this by taking the log of 6 and dividing that by the log of 3 and punching those numbers in your calculator and just solving, letting the calculator do the work. So log of 6, making sure I close the parentheses, divided by log of 3. Again, making sure I close the parentheses. comes out to 1.6309 if I round it to the 10,000th place. First 4 problems on your assignment today is just going to be doing this. Just follow the directions as to how far it tells you to solve them. So that's the change of base formula. And we use that change of base formula when we've got a base down there to an of. For the second one, it just says log base 4. Remember, if there's not anything down there, it's understood to be log base 10. But we don't need to use the change of base formula if it's log base 10. That button's on your calculator. You just hit log of 4 on your calculator. And you get 0.6021 is the value for the log of 4. And again, you don't need to punch that. You don't need to do the log of 4 divided by the log of 10. Log of 10 is just 1 anyway. So you can just punch that straight into your calculator. Same thing with the ln of 7.4. Now remember that ln, just for review, remember that's the same thing as log base e. These two things are equivalent to each other, but there's an ln button on our calculator. So anytime you see ln of something, just hit the ln button on your calculator, which is right underneath the log most of the time. Punch in 7.4, and you get 2.0015 as your solution for that. And those are just kind of using the different log things that we can use. We've got the change of base formula. We've got the base 10, just hit it in your calculator, and we've got ln. So that's going to lead then to solving exponential equations. Something like 6 to the 6x is equal to 66. So now we have to find the value of x that makes this work in this equation. So just like the other day when we had to isolate the log, we also have to isolate our base to make sure that we just have our base on the left-hand side or the right-hand side equal to some number. So you can't have any addition or subtraction or multiplication or division done to your base. If any of that's done, you need to undo it by adding, subtracting, multiplying, or dividing both sides. So in this case, we've already got it isolated. So step 1 is kind of done. It's isolated already. We've got our base equal to something. The next thing we're going to do then is we're going to write this as a logarithm. So we're going to change it to a logarithm. So as a logarithm, this becomes log. Whatever our base is going to be the base of our log. So log base 6. Our of is 66. That's going to equal our exponent 6x. And we've been doing this for a long time now. A couple weeks now, changing things from exponential to logarithmic. Now we can use the change of base formula because we've got log base 6 of 66. We can use the change of base formula to say that's equivalent to the log of 66 divided by the log of 6. And that has to equal 6x still. So you go into your calculator, log of 66 divided by log of 6, and then you get 2.3383 is equal to 6x, and I'm just rounding it to whatever. I'm not punching clear on my calculator. I'm leaving that in my calculator so I can just do the next step to solve for x, which would be to divide by 6. Divide that by 6, and I get a solution for my x value of 0.3897. And that's rounded to the 10,000th place, which you're going to have to do on your assignment today anyway. It's going to tell you to round to the 4th significant digit, which is the 10,000th place for this. Okay, so just kind of a quick review of how we do it. Isolate your base. After you've isolated your base, use the change of base formula if needed. You might just be able to use the log button. You might just be able to use the ln button. And then solve for it. Okay. So in this next one, we've got 9 to the n plus 6 plus 4 equals 36. Now we locate our base, which is 9 to the n plus 6, and notice that we've got 4 being added to it. It has to be isolated. So we have to move that 4 to the other side of the equation first. So now we're going to subtract 4 from both sides. So now I have 9 to the n plus 6 is equal to 32. So I have my base isolated. Next step then is to write it as a log. What is this as a log? Log base 9 of 32 equals n plus 6. Now go ahead, use the change of base formula to find the value of n. Go ahead and finish it up. Okay, so change of base formula, log of 32 divided by the log 9. That's going to be n plus 6. So punch log 32 on the calculator, divided by log, not ln, log 9. That's a 1.5773. Subtract 6. I got negative 4.4227-ish is equal to n. How'd we do? We okay? All right. Next one. So now, in this next one, we've got an e. That's okay. So we've got 2 times e to the 2p minus 4 equals 164. So we find our base. Okay, the base, remember, is what's being risen to an exponent. So the only thing written to an exponent is this right here. So we need to isolate that. So we've got 2 times it. So we have to divide both sides by 2. That gives me e to the 2p minus 4 equals 82. It's isolated. Now I need to write it as a log. What is this as a log? Let's just do it this way. Log base. What's my e? What's my base? No. What letter's there? E. Just e. Okay. Back here it was 9. So whatever our base is what the base is going to be for our log. What's my of? 82 equals 2p minus 4. What is log base e equivalent to? ln. Log base e is equivalent to ln. So this is ln of 82 equals 2p minus 4. Now you can just start punching in your calculator. Go ahead and finish it off. Hit ln of 82 on my calculator. ln on your calculator. Don't use, so you got your calculator out? Just erase that. 2.2034. Excuse me. That's what I got. Anybody else get that? Did I mess up? ln of 82. Add 4. Divide by 2. Oh, geez. Try this again. Never mind. Let's try it again. 4.2034. Is that better? Yeah. Ish. Yeah. Ish. It all depends on, sorry about that. Wow. Depends on how you round. It doesn't get you way down to 2, but 4 divided by 2 is not 2. You should have picked that one up right away. Next one. 9 to the 3m plus 6 plus 8 is equal to 84. Go. See if you can find the value of m that makes that work. Again, remember to isolate the base first, then write it as a log, use a change of base formula, and solve. So I should have got negative 1.343. So I subtracted 8 from both sides. That isolated my log, or my exponent. So 9 to the 3m plus 6 equals 76. Rewrote it as a log base 9 of 76, 3m plus 6. Change of base formula. So on. Writing this down, I mean, really, at this point, you should almost be able to go from here to here. Do this on your calculator. Subtract 6. Hit equals. Hit divided by 3. Hit equals. You're Algebra 2 students. You don't have to show me all of your steps at this point. You should be able to go from here to here. Don't have to. If you have to show all the steps along the way, certainly do that if it helps you. But you should be able to go there. One more. And then we'll call it good, and I'll hand out the assignment as you're doing this one. This one has a tendency to get people. Let's go negative 4 times 4 to the 3n equals negative 8. So it's negative 4 times 4 to the 3n equals negative 8. Again, remember to isolate first. Okay, so let me make sure everything's on. What am I going to do first here? Say it. This I have to divide by negative 4. That symbol right there is a multiplication symbol. So to get rid of multiplication, you have to divide. So it should be 4 to the 3n is equal to 2. That's why I wanted to do this problem. That was a common error that happened with the first hour class. Okay, you have to divide by 4. Now can we just finish it? So it's log base 4 of 2 equals 3n. So the log of 2 divided by the log of 4, it's 1/2. Divided by 3, 0.1667-ish. Somewhere right in there. And I wanted to do that one specific reason because that symbol right there, a lot of people are adding 4 instead of dividing by negative 4, which you need to be doing. That's like number 10 on your assignment today, just different numbers. Okay. So there's going to be 2 parts to your assignment today. First part is just going to be using the change of base property. So just use your calculator for the first 4. After that, it's solving, like 5 through 12 are solving, and then there's a story problem at the end. Remember, isolate the base first. Once you've got it isolated, rewrite it in logarithmic form. And use the change of base formula to solve.